Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. In this session we will design voltage regulator from 1.25 volt to 37 volt output. It is LM317T linear voltage regulator. It is a floating voltage regulator. It can provide 1.5 ampere current in the output when it is connected on the heatsink. So you can take regulated voltage as per your requirement. Let's start. I will request, if you have not subscribed my channel, please subscribe it, and if you want to watch my videos in future, you can press bell icon button. In this session we will discuss this adjustable voltage regulator. It is LM317T, LM117, LM217, LM317T. This is a 3-terminal regulator. It is used to regulate the positive voltage line. It's very simple to design. You can apply up to 40 volt and it will give output from 1.25 volt up to 37 volt. If we place in this way that its number is facing towards us, number 1 pin, that is adjustable pin, pin 2 is output, pin 3 is input voltage, positive input voltage, output, and the adjustable pin. How we can calculate the output? The V out 1.25 1 plus R2 divided by R1 plus I adjust R2. R1, that is 240 ohm resistance, and how much the resistor value we will install here, it will define the output voltage. Just only put the values and you can calculate the output voltage. You can design your own required voltage level using this component. First of all, if you want to find 240 ohm resistance, most of the time it is available in 220 ohms. It is difficult to find for 240 ohms. We can connect 220 in series with 22 ohms, 20 ohms resistor, so it will become 240 ohm resistance. But this time I am using another combination. I have 470 ohm resistance, and the other one is also 471 ohm. I will connect them in parallel. So two resistors in parallel, it will become around 235 236 ohms. We can use this combination, 470 ohms in parallel. But I have this special resistor, it is 248 ohms. Actually it is 240 ohm. We can use this one or we can use this one. Then I have this potentiometer. It is 5 kilo ohm potentiometer. We can use 10 kilo ohm, 5 kilo ohms. So I will use this 5 kilo ohm potentiometer. And if the main DC capacitor is distant about 6 inches, then we have 100 nanofarad capacitor, ceramic capacitor, we have to connect it here. In the output side, we will use 1 microfarad capacitor. So we will connect this 236 ohm resistance between the output and pin number 1. I will connect between the output pin and pin number 1. So I connected 470 ohm resistors in parallel to make around 240 ohm resistance. First of all, I will adjust this potentiometer. I will adjust around 1 kilo ohms. It is 1 kilo ohm resistance. I will use the center slider and one side pin. So we will use 1 kilo ohm resistance. Here we will connect ground. So ground is here. Input positive voltage will connected here. We will connect a polar capacitor, 1 microfarad capacitor, between the pin number 2 and the ground. The ground of the capacitor will connect it to the input ground. We will connect 0.1 microfarad capacitor, 100 nanofarad capacitor to pin 3 and the ground. This is the pin 3, that is the input pin. We will take output from this pin. Now the connections are okay. 1.25, 1 plus 1000 ohm, 240 ohms. I am connecting 236 ohms, okay. If we will connect the exact 240 ohm, then we will enter 240. 50 microampere current for the formula, and 1000 ohm, that is the variable resistor. The output voltage must be 6.6 volts. So let's connect it. I connected this 100 nanofarad capacitor between this pin and the ground pin. Between pin 3, that is the input pin, and the ground. 1 microfarad capacitor between the pin 2 and the ground pin. 240 ohm resistor between pin 2 and pin 1. Between ground and pin 1 we connected a variable resistor to take variable output from this adjustment. So we can take a voltage as per our requirements. The ground, input and output voltage. The input voltage is 21 volts. I am dropping the voltage. The voltage are dropped between 3.3 volt. The output is dropped. When I will start increasing, 6.6 plus 1.25 for the reference, at that time this IC will start regulation. Why 6.6? Because this is 1 kilo ohm resistor. 6.8 volt, still it is not regulated. 6.6 plus 1.2, so it will start regulation. At 11 volts the output is the same, and it can provide 1.5 ampere current. If you want to take full current, we must connect heat sink. We can see the output voltage are regulated. 30 volts, at 38 volt, this is the maximum limit. So the output voltage are stable. We are taking output from this pin. Now I can adjust the output. This time I connected 5 kilo ohm potentiometer. I am increasing the resistance to clockwise position. The output voltage are increasing. You can adjust as per your requirement. Just take a potentiometer and install in the panel, and you can connect a voltmeter to give output. So this power supply is now a very useful power supply. You can make it for a small current applications. The minimum voltage, that is 1.25 volts. Now when we will put it at minimum level, it is to 1.25 volt. Start increasing. It is now increasing the voltage. In this way we can take any output what we want. If you want to fix it at some position, for example, we can calculate the voltage. If I will connect 2200 ohms resistance just only in R2 value and put it here 2.2k, it will give 13 volt, 13.04. You can calculate the voltage by putting the values here, and just only connect a value instead of this potentiometer. So it will a fixed voltage regulator as per your requirement. This is a variable voltage regulator, but you can make it as a fixed voltage. For example, if you want to adjust at some voltage value, this is 9 volt. Okay, we will check the resistor value and we will verify in the formula. Now I remove power supply. It is 1.45K. 145. It is 8.938. So 1450 ohm resistance will connected in place of this potentiometer. For example, I want to take 19.5 volts. Just only adjust it. This is 9.35 and it will regulate it. 36 in, output is 19.5 volt, and if you want to take at full current 1.5 ampere, always install the heatsink to maintain the temperature. I hope so this video is informative. If it is informative, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum warahmatullahi wabarakatuh.